welcome back, and we're solving another very interesting problem today. And this shows up pretty often on interviews, so please pay attention. So the goal of the problem is to search for an integer in an array which occurs more frequently than others. So basically you have a list of integers and you are trying to find so you have a list of integers, okay, and the second thing is you know that there is one integer that occurs 50% of the time or more. There is one integer that occurs more frequently than others. So basically you are saying that if there are n integers in all in the list, there is an integer, say x, which occurs m times in the sequence of n integers, and m by n is greater than half. That means that element m is the majority element and it occurs more often than others, and it occurs more than 50% of the time. But the trick is, or the problem is, you don't know which one of the integer has that frequency. So you want to figure out from the stream of integers that are being coming to you, which one is the majority, which one occurs more than 50% of the times. So you know there exists such an integer in the list which occurs more than 50% of the times, but you don't know which one. So you have to figure out which one is that integer. So you have the total number of streaming integers that you are observing is n, and the element x, which is the majority, occurs m number of times out of those n streams, and you know that m by n is greater than half. Now you have to figure out which one of those elements has the frequency. So basically you have to figure out the value of x. Now how will you solve this very interesting problem? So you know one element is more frequent than others, it's more than 50% of the time it occurs, but you don't know which one. Now think about it for some time. So as you are observing the sequence of integers in the stream, one thing you know for sure, that the moment you get two distinct integers, you can throw them away. Why? Because if you throw two distinct integers, there are two possibilities. One is, one of them is the most frequent integer. The other one is none of them are frequent integers. So what happens after you throw away those two integers to the frequency of occurrence? So in the case 1 is none of them are the most frequent integers. So none of them are x. None of them is x, okay? So in that case, what happens to the remainder? So now we have thrown away two integers, so the total number of integers left is n minus 2, out of which x occurs m times. So the ratio of that is m by n minus 2. And case 2 is, you threw away two distinct integers and one of them was really x, but you don't know which one. So what happens is, the remainder of integers is n minus 2, but number of x, the element left, is m minus 1 now, because you have already thrown away one of them. Now, if m by n is shown to be greater than half, then you can easily see that m by n minus 2 is still greater than half, and m minus 1 by n minus 2 is still greater than half. So what the principle is telling is that if you throw away two distinct integers, the majority element that was there before you threw away the integer still remains the majority element after you threw away the integers. So the remainder of this stream still has x as the majority. So that's a very elegant observation, because all you have to do is go over the list once, and the moment you see two elements which are distinct, just throw them away, and at the end whatever is left is the majority element. So that's a very elegant solution, and let's code up that solution. Okay, so find major element is your solution, and input to this is your integer list, say a. Okay, so you start with current pointer, so integer current int that you're looking at, and the next int. And you also keep track of your count. So all you are now doing is you're just reading the next integer from the stream, and if it's the first element, that is count equal to 0, all you are doing is you're storing it in the candidate. So candidate, which is the current int. So this current int is equal to next int, which you just read in, and then you increment the count. Otherwise, there is another possibility, is that the else part. It may be possible that your current int or the candidate is equal to the next int. In that case, you don't do anything, because you don't know, you don't have that assumption here that you have two distinct elements and then you can throw away. So in this case, you cannot throw away anything. All you do is simply increment the count. Okay? And otherwise, all you do is throw away whatever you got. So you got two elements now. The current integer, which is sitting there from your previous array, and the next int that you just read in. So you just discard both of them, and by discarding you mean reduce the count. Count is reduced. Okay? And at the end of this iteration, whatever stays in the candidate or the current int is your majority element. So just go back and at the end just return the current int. Okay? That's your answer. So this is a very elegant